Hello and welcome back. I'm going to be starting part 2 of the video on how to use SigmaPlot to graph our data that we get from our bioassays and return an IC50 value. So if you haven't seen part 1, at the end of that we got our data here into this format, which is the format that we want, right? Where we have our values for fluorescence for each individual well, right? This is how the plate is set out. So we have each compound is in its own row, and each column represents something specific. So 1 through 8, those columns are our actual fluorescent dilution from a concentration of 0.4 all the way down to 0.000183 millimolar, and that is for a 20 millimolar sample. Columns 9 and 10 are our negative control, so this has no inhibitor in it, so this should be our maximum absorbance or our maximum fluorescence, sorry. And then columns 11 and 12 are our blanks, our backgrounds that the instrument takes and then subtracts from all this data to make sure that we aren't also including background light. So the first thing that we need to do is open SigmaPlot. So it'll take a second to open. When it opens, it'll give you this option here, where it'll tell you and ask you where you want to create something. So you can either click Open Existing File and this More Files button to open something that already exists, right? If you're going to continue work on something you started earlier and you want that all in one individual file, that is what a notebook is, right? A notebook is just a word for the file that contains all your experiments. For this, let's create a blank notebook, which is what you might do. Doesn't matter if things are highlighted. If this is selected, it'll go ahead and open. Okay. And this is what it'll look like. On the left-hand side, you have this sort of notebook manager, which you can turn on and off by clicking on this button in the home page, the notebook manager button. I like to leave it on because I think it's pretty easy to see how everything's working, but you can change that as you like. You see you have cells here. They operate very similar to Excel. The only difference is you can't really put equations in here the same way that you can in Excel. So let's go ahead and get our data. What I like to do is in the very first column, I like to put the concentrations. So let's open our Excel. You want to select the values, copy them, and paste them in. Now again, you want to make sure that you are remembering to label all of your stuff. So I like to write what these are. Concentration. And then this is the concentration as it should be for a compound that is 20 millimolar to start with. Concentration in millimolar, right? And what we can do is we can stretch this out so we can see all of that. A different way you could do this is you can also, if you double click at the top here where this number 1 is, you can rename this as well. So if you don't want your labels in the actual text box or in the cells, you can label it up here, right? And either one works. It won't change anything and it won't affect your data either way. So we have our concentration in, and you only ever need to put this in once, and you'll see why. It's because we're going to manually select this data. So we go ahead and put that in, and let's do our very first compound. Let's pick this one. This isn't a positive control, which is our letrozole. This is actually a compound that we've used. So what we want to do is select all of our data by highlighting it and clicking Control-C, and then Control-V to paste it. And again, we want to label it exactly as it's labeled in the Excel document, right? So this means that this is compound MnA148, and this is one run, right? So this is on row E right here, and this is on row F right here. So now that we have this ready, we're actually ready to go ahead and start creating our graph. So the first thing we do is we come to the Create Graph tab, and we click Graph Wizard. You want to make sure that scatter plot is highlighted. There are tons of different graph types in here. We want a scatter plot, so make sure that's highlighted. Then click Next. We want to make sure that simple scatter is highlighted. Click Next. We want to make sure it's an XY pair. We aren't doing only one or the other, right? So XY pair is highlighted and click Next. And then we need to select our data. So what we do for the X, that is going to always be our concentration. So we can click and drag in the window, and it will go ahead and select this for us. So you see there it's X, it's concentration, and it's rows 1 through 9, and that's what we want. If you need to change that, you can simply highlight it again and change it. Just make sure that it is your concentration on the X. And then for Y, we want our fluorescent values. So we click and drag on our fluorescent values, and it puts that in there, column 2, rows 1 through 9. Once that is set, all you can do is finish, and it creates this graph for you. So let's zoom in on this a little bit so you can see. You can see that this is not what we're looking like. This is sort of almost like an inverse exponential graph, right? What we want is sort of the like upside down S shape, right? That sinusoidal plot. So to get it to look sort of how we want it, right? First on the X data, we need to change this, the scaling, right? Because we want the scaling to be logarithmic. So first you can double click on the points down here to open up your graph properties page. You go to scaling, and for the X axis, you change this from linear to log common. Okay. And you can see that already has sort of fixed it. And then on the Y data, so you can either close this window and double click on these values on the Y axis, just like we did to open this one, or you can come up here to axis and change this to Y data, and it'll automatically select it for you. We want to change the Y data to make sure it starts at 0. Okay, so we close this, and now you can see it looks more like what we want. You can imagine if you sort of connected these dots, there would be sort of a little S in the middle. But that is all you need to do for the graph to prepare it to create the regression. Now, we want to actually go through and get that graph and get that IC50 value. So you come over to Analysis up here at the top on the tab, and you click on Regression Wizard. The first thing you want to do, though, before you click that, is you want to select all of these points. The easiest way to do that is you just click one time on one of the points. It'll select them all. You see how they all turn to these sort of transparent boxes. You have to be careful because sometimes if you double click, you might open this box. You can also accidentally only select one value, right? So if I did something like that, see now one of these dots is not selected. And if I try to select that one, it's going to select that and not select the others. If you have problems with this, the easiest way to reset this is simply to click off of this page. So you can click either on the tabs up here to change, or on these headers on the left. So I just click over, and then I just come back to the graph page, and it's fixed. It's either all highlighted or all unhighlighted. You can redo it. Additionally, another thing, if you're trying to keep track of what graph is what, because you can put all the data in, create all the graphs, and then do all the regressions, or you can do it one at a time. You can change the name of the graph here. I find it's very easy. You just double click, and you can change the name of this graph. So let's call it MN148. So I just don't lose track of it. There's no other graphs, but if I create another one, you never know. So now this whole tab is named, and we can always have this open and know which one this relates to. So we click to make sure everything is selected, right? You should only see 8 points, right? Because if you think about it, that 9th point, remember down here, the 9th point, it's actually at 0. So it's still included. It's just not shown on the graph because a logarithm can't go to 0, right? That doesn't exist. Some basic calculus review. But we will change that so it does appear on the graph later. That's okay. As long as everything that you see on the graph is selected, it'll be selected. So you click on Regression Wizard, and that will open this window. It might not be set on this, so sometimes it'll be set here. What we need to change is we need this to be, oops, let me find it in this list, a standard curve, all the way down here at the bottom. This list is a little hard to see here. A standard curve, and we want this to be a 4-parameter logistic curve, right? And you can see that it's actually going to put the EC50 value, which is our IC50 value, that's elimination concentration, right? That will actually be put inside of the equation for us, and so it'll edit it. Another thing you need to check on this window is you need to click on Edit Code and make sure that these two things are listed. So you need it to say max greater than min, and it needs to say hill slope equals -1. This is to make sure that everything goes according to the equation and we don't have any really funky like negative values or anything like that. That wouldn't be very good. Additionally, another thing you can change if you need to edit this, and this information is at the end of the instruction document, which I will show you at the end of this sort of section, is you can change the iterations and the tolerance if you are having a really hard time getting it to work. Sometimes it'll say, did not fall within tolerance, and so you might have to change this value in order to get it to tolerate a sort of larger range of values. And I'll talk about that a little bit later. So as long as these values are okay, it says max is greater than min, and it says hill slope equals -1. This section doesn't really matter. If it's there, it's fine. If it's not, it's okay. Just hit OK. And then you hit next. You shouldn't need to change anything on here. All it's doing is saying that your X data is in the column 1 and Y data is in column 2. If you didn't select the points, you'll have to manually select these options, right? But that's what happens if you don't select the points. You just have to go onto your data tab and select these two. You hit next, and you need to pause at this page. This page is very, very important because right here, it reports that EC50 value, and this EC50 value is your IC50 value. So you want to get a little separate piece of paper off to the side and just write that down. -3, right? And the good thing to remember is that this is going to be in whatever scale your x-axis currently is in. So our x-axis is actually right now in millimolar. So in order to get this to be in micromolar, right, we need to add 3, right, because micromolar is 1,000 times, it's e to the -3 times smaller than milli, right, from milli to micro. So what that means is this is actually going to be 2.428 times e to the 0 micromolar, right? And that's a really important thing to note, is this will report it in whatever scale, whatever value your x-axis is in. So you always have to remember that and make sure to make that conversion, because 2.428 micromolar is really good. 2.428 times e to the -3 micromolar is way different, right? It's really, really good, and that we don't want to report something that's wrong, right? So just make a note of that, because you always do want to report these in terms of micromole. Once you have that value written down, let's look at a couple of other things on this page. It does give you the standard error, right? So this standard error is at least an order of magnitude smaller than this, so that's good. It also tells you up here at the top of this window, converged in 9 iterations and tolerance was satisfied. If it doesn't converge or your tolerance isn't satisfied, you may want to try and readjust some of those values I showed you in that code window to get it to converge and to get the tolerance to be satisfied. Because if it's not satisfied, the data is a little suspect, because it means it's either taking a best guess or just reporting whatever data, whatever EC50 value it calculated last, not necessarily the correct one. So you want to be careful, But if it says converged in any number of iterations and it says the tolerance is satisfied, you're good to go. So after that, we hit next. You always want to make sure that this box right here, create report, is unchecked. You don't want to create a report. What it will do is it will open up a new page. And all that'll tell you is all that stuff you saw previously. You don't need the report. It's just extra data, right? So after that is unchecked, you can click next. And you want to make sure that you are adding this curve to your graph, right? So if you select the data points, it will almost always add it to the graph, but sometimes it's good to check, especially if you have multiple graphs. Sometimes it has a little bit of a problem picking the right graph to add to. And so it's saying 2D graph 1, and this, remember, this is data 1. It's saying the title. So this is titled 2D graph 1. So it will add the curve to this graph, which is what we want. So then all you have to do, you can go through more, but you can just hit finish at this point. And there you go. It's added this curve to our graph. And this is a very nice, you see, sinusoidal curve, right? And that's really it, right? You have that value written down. You have this. The rest of it is all formatting and how to get this to look nice. And that is going to be in the next video. But you have your curve and you have your IC50 value for this run. Thank you, and I will see you in part 3.